Problem 5. This is a problem that my previous year's class continually had difficulty with. And it's not because they couldn't do the math. They all knew the math. It was more of a problem of reading the problem and taking what they're asking you to find and what you're given and putting it into the diagram accurately. So before we even read the problem, we should just take a moment and look and see what this picture is representing. And I can see this side right here is the actual tree, okay? And what's on the ground, ironically enough, or coincidentally I guess, is the ground. You know, what goes across the bottom is the ground. It could be a shadow. I just don't know. You know, maybe there's a sun there, and you know it's beaming down and it's casting a shadow on the ground. But we'll see. The hypotenuse is the weird thing. It's not really anything, and you can see that in how they dashed it out. It's just something we're going to use to help us figure out either the height of the tree or the length of the shadow that it makes with the ground. We'll see. Let's go ahead and read this problem now. It says, as shown in the diagram below, the angle of elevation, that's this thing, is 34 degrees. From the top of the tree to the ground. They tell me if the point is 20 feet from the base of the tree. So the point is where that angle of elevation is starts. And the key to letting you know that is point, and then it's from the base of the tree. That's kind of telling me it's like, oh, it runs along the bottom. And if you still don't buy that, and maybe if you're like, well, maybe the point's up here, and it's saying it goes straight down to the base of the tree, you can rule it out by reading the next part, what they're specifically asking you to find. They're saying, what is the height? What is the height of the tree? Well, the height of the tree is that vertical thing. That's what we're looking for. So I'm going to call that X. So that leaves either the ground to be 20 feet or that hypotenuse. And that hypotenuse doesn't really make sense to be 20 feet because it says it's from a point and it's from the base of the tree. That's the bottom. And that's how I know it goes from here all the way to the base of the tree. And that's how I know that 20 feet goes down here. So when I go to label my triangle now with hypotenuse, opposite, and adjacent, I can see right there my 90 degree goes here. Therefore that points to the hypotenuse. I can use my reference angle to see that the height of the tree is what's going to be called opposite. It's opposite my reference angle. And therefore that 20 feet on the ground, that's the adjacent. And I'm using opposite and adjacent, and that's a tangent thing. And because I'm looking for a side, because I'm looking for the height, that's going to be normal trig. So that's going to be the tangent of my reference angle, 34. That's going to equal the opposite over the adjacent. And the opposite is my x. That goes on top. And the adjacent, 20, goes on the bottom. X won't always go on top. It's just more of what does the trig function dictate. And it says that the opposite has to go on top. And it's just in this case, our opposite is in fact x. Let's toss this over 1 and cross multiply. X will come down, and then x is going to be equal to the product of 20 and the tangent of 34. That multiplication will tell us what the height of our tree is, what the value of x is. So I'm just going to type that into my calculator. 20 times the tangent of 34. When those operations are, or when those numbers are joined together like that, it's implied that it's multiplication, and I can see it's 13.490. Just to show you, I can do 20 times tangent 34, and I could do 20 parentheses the tangent 34. And it's all going to give me the same 13.490. So x equals 13.490. And they want me to round to the nearest tenth. So I need to know, do I keep that a 4? Well, I look to the right. It's greater than 5, so that 4 is going to get rounded up to a 13.5. X will equal 13.5. 0.5.